This is a demonstration video showing some of the chemical characteristics of oxygen along with the use of oxygen in gas cutting equipment. Oxygen is a diatomic gas under normal conditions, occupying approximately 20.9% of the volume of the air that we're currently breathing. Oxygen can also form ozone, O3, which is found in the ozone layer, protecting us on the ground from the harmful effects of ultraviolet radiation. In the first demonstration, we're going to show how oxygen supports combustion by lighting a small piece of wood with a hole drilled through under a low flow of oxygen. With the wood burning, if we turn up the flow rate of oxygen, combustion is accelerated. Even with the video sped up, you can see that increased oxygen accelerates combustion. In the next demonstration, we're going to produce some liquid oxygen and look at some of the properties associated with liquid oxygen. To produce liquid oxygen, we can use a bath of liquid nitrogen to cool a flask containing gaseous oxygen at a slight overpressure. Due to the difference in boiling points, after a short while, a pale blue liquid is formed in the flask. This is liquid oxygen. Now if we pour the liquid oxygen into a test tube, which is supported on a wire, you can see the liquid oxygen boiling away as it's cooling the test tube down. Now if we hold a permanent magnet close to the base of the test tube, you can see the test tube is attracted to the magnet. This is because liquid oxygen exhibits paramagnetic behavior, meaning it is attracted to a magnetic field. Liquid oxygen, like gaseous oxygen, also supports combustion, as we can see here. And now we'll watch that in slow motion. As liquid oxygen is added to a burning fuel, when they come into contact, combustion is accelerated. And we'll watch that reaction one more time, but this time with a little less liquid oxygen, but we have the same result. Now in our final demonstration, we're going to show the practical application of oxygen in a cutting torch. A cutting torch is made up of various components, as shown here. One of the key components is the tip of the torch. On the end of the tip there is a series of holes, and when you look down the tip you can see a rather large hole in the center. This is where oxygen is fed when the cutting lever is depressed. To light a cutting torch, first you turn on the fuel, then light the gas. In this case we're using acetylene, which burns with a dark red-orange flame without additional oxygen. Once we add additional oxygen by turning the valve, you can see the flame turns blue. Because added oxygen is improving the efficiency of burning the acetylene, the tips of the cones inside the torch are approximately 2000 degrees Celsius or around 3500 degrees Fahrenheit. Now let's see the cutting torch in action. In this case we're going to cut a mild steel pipe with a wall thickness of about 1/4 of an inch or 6 millimeters. So initially we preheat an area of the steel until it goes white hot with the torch. Then we depress the lever, which increases the flow of oxygen through the center of the tip on the torch. This oxygen reacts with the hot steel, oxidizing the iron, forming iron oxide, and in the process that jet of oxygen cuts through the steel. Now once this process is started, this is exothermic and enough energy is being generated by the reaction of oxygen and iron that it is possible to continuously cut the steel by just using oxygen through the cutting torch. Thanks for watching.